Okay, here's an example of solving inequalities involving absolute values, and this is example number 1. I've got a couple examples here I'll show you. And this is a more complicated one, but you can follow the work, and then you may have simpler ones that will continue at different stages of the evolution of the solution. So first of all, what we want to do is we want to isolate just the absolute value. So we want just this part here, just something like that. So we could treat this like this was an equation, and we could call the absolute value, let's say the absolute value of 2x minus 1 was y. This would be like 4 minus 3y is less than negative 11. So if we had this inequality, how would you solve that? Well, the first thing you'd want to do is remove the 4 from both sides and then the 3, and then you would have just the y. And that's what we're trying to do over here. So the first thing we'll do is just subtract 4 from both sides. And we end up with negative 3 times the absolute value of 2x minus 1 is less than negative 15. And you might see a problem like this, and you know where to go from here. Then we want to, and remember we can add or subtract both sides of the equation by a number. We can also multiply or divide by, the inequality. We can add or subtract both sides of an inequality by the same number, and it won't change the direction of the inequality. We can also multiply and divide by a positive and won't change the direction, but if we multiply or divide by a negative, it will change the direction of the inequality. And that's what I'm going to have to do here, because I want to isolate this 2x minus 1, so I have to remove the negative 3, so I'll divide both sides by negative 3. So when I divide by a negative, I know I've got to change the direction of the inequality. So what I do is I circle that inequality because I'm divided by negative 3, and I know the next time I write it down, if I want to remove that circle, I've got to change direction. And now I've got the absolute value of 2x minus 1 is greater than, and a negative 15 divided by negative 3 is 5. Now I have to decide what I'm going to do with this greater than. Now, we can use the definition of the absolute value to work this out, but it's kind of complicated. So we'll just tell you that if we have a greater than, it's going to be what we call a disjunction. If we have less than, it's going to be what we call a conjunction, an and. Now you have to remember that. Now an easy way I have of remembering it, and this seems a little bit kind of non-mathematical, but it works, is if I look at this, I notice that I can make that into an R real easy. So then this is going to be an OR. Doesn't look like I can make that into an R real easy, so that's going to, the other one's going to be an AND. So that's the way I do it. And, I mean, it works for a lot of people, so try that. So now we can rewrite this as a disjunction, or, and what we do is we write this without the inequality, just exactly the way it is, but without the inequality on the right side. 2x minus 1 is greater than 5. And then on the left side, we write the part that's inside the inequality, 2x minus 1. And then we reverse and negate. So we reverse the direction of the inequality, and we negate whatever this is. If this is a positive, we make it a negative. If it's a negative, we make it a positive. So in this case, it's a positive, so I make it as a negative. So now I have two relatively easy inequalities to solve. So first of all, I'm going to add 1. Now, the left sides are going to be the same. It's just the right sides that will be different. So you'll do the same operation. So I'm going to add 1. And on the left, I've got 2x is less than negative 4, or 2x is greater than 6. So there's my or. And then I'll divide everything by 2. And now I have x is less than negative 2, or x is greater than 3. There we go. Now we can graph, we can write the solution like that, or we can graph it on a number line, and that's not too difficult. Here's the number line down here. Now it's greater than, but not greater than or equal, so at 3 I would have a circle, and I could fill it in like that, and at -2 I would have a circle, and it's going to be less than -2 or to the left of -2, greater than 3 or to the right of 3. Now we can also use interval notation, and this is going to be -infinity all the way to -2, and this is going to be 3 all the way to infinity, and if we want to say it's going to be this or this, we can use this for the union. And there's your solution. Okay, so I hope that covers everything. And as I said, you have various steps, so you might, if you see a problem like this, you know where to go. If you see a problem like this, you know where to go. If you see a problem like this, you know where to go.